Hi everyone, this is to discuss the questions chosen from Cambridge PU for the math. We will look at polar coordinates for today, so the questions are also suitable for Cambridge International syllabus for the Pure 1. Okay, first question that we have here is we have the curve given, okay, I is equals to 1 over 1 plus theta. So if you actually look at the range for the theta is from 0 to 2 pi, means it's going to cover everything, and when theta increases, the r will actually decreases. Okay, so when theta is equals to 0, okay, we have r is equals to 1. Okay, so for this one, okay, we know that the r is going to decrease, okay, starting from this one. So we just have to make sure that when we actually sketch the graph, it is actually going up bigger until we have actually a smaller r from there. Okay, so this is what we expect from this graph. Okay, so basically that is for our part 1. Part 2, find in terms of pi, okay, the area of the region enclosed by the curve and part of the initial line between the endpoints of the curve. Basically, this is everything, okay, for the area that we need to evaluate. So for this one, we know that in order for us to find the area, so our area here is given by integrate half r square d theta. Okay, so let's just pull out the half, and then we have got the limits for theta. Of course, it's from 0 to 2 pi because it's everything. And we have got the r is 1 over 1 plus theta, and then just remember to square this, okay, before we integrate. So after that, that would be half, and then we have got negative 1 over 1 plus theta. So this is after we integrate. So we need to evaluate this at 2 pi and 0. So if you actually do that, okay, we will actually have this is 1 over 1 minus 1 over 1 plus 2 pi. Okay, and we can actually evaluate this a little bit. So half, and this is just to simplify. So make the two terms into a single term. Okay, so if we actually evaluate nicely and simplify nicely, so we should be able to get this expression, okay, in terms of pi as a single fraction. Okay, so that's for the first question here. The second one is to sketch the curve with polar equation r is equals to modulus of half plus sine theta, okay, for in this case the theta here is a 0 to 2 pi. Okay, so for the first part of the sketching, okay, if we have in this polar equation, if there is a trigo involved, okay, we usually first sketch out the trigo curve first because we want to see how our r changes, okay, when our theta changes. So this is what happened to the first part of the graph, where we have the r theta graph as if we sketch the usual trigo graph first. So of course we have got some important points here that we need to take note lah, basically. Okay, so by looking at this behavior, okay, because this is a modulus, remember, so we have to reflect, okay, whatever below the horizontal axis up. And we have some very important points here, which we have the 7 pi over 6, which gives us r equals to 0, and 11 pi over 6, which gives us r equals to 0 as well. So whenever we have like this kind of the point, which is like indicate that r is equals to 0, so it is actually good for us to actually mark them here. So you can see like these two, okay, are the two lines that we actually mark. So we don't mark them as a solid line, just use a dotted line will do to indicate that, okay, at that point the data is these two values, and then the r would be 0 in that case. So after that, when we actually try to change, okay, this the first graph to the polar curve, so just have to look at the behavior of the graphs. So initially when r equals to 0, we have the theta equals to 0, sorry, the I is equals to half, so we have got a half here. So let's say this is our half, and when it goes to theta equals to pi over 2, we have got 3 over 2. Okay, and when we have pi, okay, the r is 1 over 2 again. Okay, so when it goes to 7 pi over 6, the r actually becomes a 0. So we need to go back to this point 0. And when it comes to 3 over 2, okay, the r is half again, and then just follow this curve, okay, behavior, and we can actually sketch out what happened to the curve. So from half to 3 over 2 to 1 over 2 again, and when it goes to the 7 pi over 6, it actually goes to 0. So from 0 to this r is equal to half, okay, so we have got from theta equals to 7 pi over 6, when it goes to 3 pi over 2, we have a certain value, okay, which is a half. So the rest of it is symmetrical, so we can just copy, okay, the rest of the behavior of the graph. Okay, so this is what happened to our graph by looking at the behavior of the r as the theta changes. Okay, next one. Find in exact form the total area enclosed by the curve. So when we want to find the total area, so it is not necessarily for us to use the whole range of the theta, because we can always rely on the symmetrical property. So for this symmetrical property, we can see that this curve is symmetric at the y-axis. So if we want to find the area, we can actually double, okay, the area of this curve from negative pi over 2 to pi over 2. Just have to use the part of the curve where it is to the right of the y-axis. So the area that we are looking at for this one is the area is 2 times, remember, half of integrate, okay, the r squared d theta. So the limits that we put here is negative pi over 2 to pi over 2. So this is we are using the part of the curve which is to the right, okay, of the y-axis to find out. So we also have the r squared. So the r squared here is half plus sine theta squared d theta. So basically is to expand the half plus sine theta first, then we will see what we can do from there. So expanding gives us 1 over 4 plus sine theta plus sine square theta d theta. So we know that we cannot just simply integrate the sine squared or cos squared, okay, term. So we have to rely on the double angle to help us to integrate. So we have to change the sine squared to the double angle first. So it is always, we can use the cos 2 theta formula for that. So after we change it, so the sine squared theta will actually gives us half minus half cos 2 theta. So this is basically based on cos 2 theta is equals to 1 minus 2 sine squared theta. Okay, so we just manipulate from there to get the sine squared theta as a subject. Then we can just substitute that here. So before we integrate, okay, we might want to tidy up a little bit because we have got the constant there. So we have got 1 over 4 and 1 over 2, which gives us 3 over 4, and the rest just remain. Okay, so after that we are good to go. So we can integrate this. So integrating a sine theta gives us negative cos theta. And integrating a cos 2 theta, sorry, I missed out a half here. So this one should be a half. So integrate the cos 2 theta gives us half sine 2 theta, which actually gives us 1 over 4 sine 2 theta as that term. So evaluating these values at negative pi over 2 to pi over 2. So basically the evaluating work, okay, it's good for us to show the working for everything. Okay, so don't feel like you want to skip this step, because by substituting the values in, we are clear that what are we actually evaluating. Okay, so you can also do the same thing for negative pi over 2. Okay, so after evaluating this bunch of the values, okay, we found out that the first term is 3 pi over 8. The second part is actually also 3 pi over 8. So adding them actually gives us 3 pi over 4. Just have to evaluate the values carefully from there. Alright, so we can actually look at the next one. Next one is from summer 15, question 4. So for this, okay, we have r is equals to sine half theta, and we're supposed to sketch this curve. So this curve is not difficult to do actually. So we can actually sketch out what is the curve for r equals to sine half theta first. So on the left hand side that you can see here is what we have for the behavior for the theta and r. So from there we just have to change this, okay, behavior of the theta and r to the xy plane. So at first we know that we have got r is equals to 0, okay, and then when it actually goes to the pi, okay, the r is a 1 here, okay. So okay, this is what we can get for the first half of the graph, which is from 0 to pi. And then from pi to 2 pi, because of the symmetry property, as you can see from the graph from the left hand side, we just have to copy whatever that we have done in the positive y part. So the negative y part will be symmetry as well. Okay, so as easy as this for the sketching. For second part, determine the area of the region, okay, enclosed by the curve. So again, we are using the half r squared theta when we integrate it. So for this one, we can again use the symmetry property. So we can just use the first, the upper half of the graph. So in this case, the area is just 2 times half integrate r squared d theta. So r squared here is sine squared half theta d theta. The limits just 0 to pi. Okay, we just have to use the upper part of the curve. So tidy up a little bit first before we actually start integrating. So 2.5 we cancelled off. We'll get a 1 actually. So sine squared half theta, again we will actually use the double angle, which is similar to what we did in the previous question. So basically the integrating stuff is not difficult at all to do. And we just have to evaluate it, okay, at the pi and the 0. So basically if actually evaluate it, we should be able to get half pi for this area. Okay, so this is not difficult to do. Okay, next one. We have from summer 14, the question 11. So a curve has polar equation r is equals to e to the power of sine theta. So first, okay, state the polar coordinates of the point where the curve cross the initial line. So this is, the initial line means the theta is equal to 0. So when theta equals to 0, we have got r is equals to e to the power of 0, which is equals to 1. Okay, so in that case, when we have the initial line, which is x-axis, so the y coordinate will be 0, and then we have the r is equals to 1. So in that case, that will be the 1, 0 is where the curve crossed the initial line. Okay, part 2. State also the polar coordinates of the point, okay, where r takes its least and the greatest value. So how do we actually look at this is that we have the sine theta. So we know that the sine theta can only take a certain value, which is the sine theta can only take from -1 to 1. So we already know what is the maximum and the minimum r in this case. Okay, so the minimum r, okay, the minimum r will actually occur when we have the theta equals to -1, which gives us r is equals to e to the power of -1 when we have the theta is equals to when we have the sine theta. It's easier to look at that. So sine theta is equals to -1. So in that case, the minimum point is we have the coordinates, the polar coordinates is in the form of r theta. So the r in this case is e to the power -1. The theta is negative pi over 2. Okay, because that is when we have the sine theta is equals to -1. So our theta will be a negative pi over 2. Maximum is a similar idea. So we have r is equals to e to the power of 1 when what happened is that the sine theta is a 1. So when sine theta is a 1, we have the r is e power 1, and then the theta here is when we have the theta is pi over 2, because because sine pi over 2 gives us a 1. Okay, so that is the second part. The third part is to sketch the curve. So basically, when we actually ask to sketch the curve after we have asked to do like the first two parts of the question, so it's definitely to help us. Okay, the values that we have got in the first two part is going to help us. So what we know is, okay, the curve is going to cross the initial line at 1, 0. So we know this is 1, 0. Okay, so we know the curve will start here, and then we also have the minimum r. So the minimum r occur at the angle, the theta, which is negative pi over 2. So this is where our minimum r will occur. Okay, so this value is e to the power of negative 1. Okay, and for this maximum, it will actually be e. Okay, so we have got e for this, and then it occurs at the angle of pi over 2. So basically for this one, okay, the graph actually looks like this one. Okay, you can draw a better graph than mine. So basically, this curve is symmetric, okay, at the y-axis. So this one is a negative 1. Okay, because what we can do is we can also try out what is the value of the r. Let's say theta is equals to pi. So we also have the r is equals to e to the power of sine pi. So sine pi is a 0. So we actually gives us the r is a 1. So it should be symmetrical at the y-axis. Okay, because we have got the sine theta. Okay, the sine theta is symmetric. The graph of sine theta is symmetric. Okay, at the pi. So we have for this one, because this one we have the value, which is we have got the theta goes from negative pi to pi. So this graph, okay, should be symmetrical at the y-axis. Okay, so we move on to the next one. So for the next one, by deriving a suitable Maclaurin series, okay, up to and including the term in theta squared. So find an approximation to 3 decimal places. So find for the area of the region. So for this one is basically the content from the FP2. Okay, so if you are familiar with the FP2, so we can actually do this. So what they actually need here is we want to find the area. So because the area depends on the half r squared theta. Half r squared d theta, we are going to integrate that. So we need to find out what is the expression for half r squared. Okay, so we are not going to integrate the r squared straight away, but instead we use the Maclaurin series of it. So what do we mean by here is, because we need to use a half r squared, right? So just let the r squared to be the function that we want to find out the Maclaurin series. Okay, so this is what we have for the r squared. So let's just call it as an f theta. Okay, so in order for us to find the Maclaurin series, we need to evaluate the values of the theta equals to 0. Okay, so in that case, we have f of 0 is equals to e power 0, which is a 1. Okay, so do the same thing for the rest. Okay, we have to find the higher derivatives of it. So f prime theta is 2 cos theta. So we differentiate the power and we remain the term. Okay, so we need to evaluate the f prime 0 as well. So when we evaluate the f prime 0, we get a 2. So we need up until the theta squared term, so we have to do one more time of the differentiation. So this one we need to use the product rule. So when we use the product rule, we will get 4 cos squared theta e to the power of 2 sine theta, and we have negative 2 sine theta e to the power of 2 sine theta. which when we actually evaluate this function at theta equals to 0, we will get a 4. Okay, so basically what we can do for this r squared is that we can now express the r squared as, so by using the Maclaurin series, so the first term is f0 plus f prime 0 divided by 1 factorial x, so the x here is not x, it's a theta, plus f double prime 0 divided by 2 factorial, and then we have got the x squared. So in this case, it's a theta squared. So in this case, okay, the r would be 1 plus 2 theta, and we have got 2 theta squared. So now if you want to find the area is to integrate half r squared theta. So just use the r squared that we have derived here. So the area that we're looking at is from 0 to 0.3 as stated in the question. So this is not difficult to integrate. So we all know how to integrate this one. And just substitute the 0.3 inside and evaluate, we should be able to get 0.204. Okay, so that is for the question from summer 13. Sorry, summer 14 should be. Okay, next one. Summer 2012. Find the area enclosed by the curve, okay, with polar equation r is equal to sine theta plus cos theta. So basically, there's no other things given. Okay, we are just asked to find the area from 0 to half pi for the theta of this polar equation. So basically, this one is not really something which is really difficult. We just have to recall how do we get the area. So the area is again half integrate r squared d theta, and we are integrating from 0 to half pi. So this is the range given for the theta. So in this case, the r squared is a sine theta plus cos theta squared. So just explain this one. So we will actually have sine squared theta plus cos squared theta plus 2 sine theta cos theta d theta. So when we actually expand, it is a good expression because we have sine squared theta plus cos squared theta is a 1, and then we also have 2 sine theta cos theta is a sine 2 theta. So by expressing it into the double angle, in this case, it will be much more easier to integrate. So the work after that is just the integration. So theta, after we integrate a 1, so when we integrate sine 2 theta, we get negative half cos 2 theta. So we have half pi and 0. So basically is to evaluate the values carefully. So we have half pi minus half. Okay, this is cos pi minus 0 minus half cos 0. Okay, so remember to put a bracket to it. So basically is to calculate everything nicely. So we should be able to get the final answer. Okay, so that would be for this question 4 marks. Okay, next one. So for this question, winter 13, question 5. So this curve S, okay, has polar equation given by this. So determine the polar coordinates of the points on S, okay, where we have dr d theta is equal to 0. So the direction is actually quite clear. We just need to find out what is the dr d theta in this case. So dr d theta in this case is cos theta plus 2 sine theta cos theta. Okay, so it should be very familiar to all of us, okay, on how to differentiate this one. So equate this to a 0. So we can actually factorize out the cos theta, and we'll actually have 2 equations to solve. Okay, so for this one, we actually have cos theta equals to 0, which actually gives us the theta is a pi over 2 and 3 pi over 2. And at the same time, we have the sine theta is a negative half. Okay, so for this one, the values of the sine theta equals to -half, the theta should give us 7 pi over 6 and 11 pi over 6. Okay, we need to find out the r, the corresponding r in this case. So we have got when we have the theta is equals to pi over 2. Okay, when theta is equals to pi over 2, the r in this case is a 1. Sorry, it's a 3 because we have got 1 plus sine pi over 2 plus sine square pi over 2. It should be a 3. So we have got 1 point which is 3 pi over 2, okay, and so on. So we have got after we actually calculate the values for the theta for all the 4 thetas, which should be able to get a series of the points. So when we have theta is equals to 3 pi over 2, the r is 1, okay. So also we have when theta is equals to 7 pi over 6, we have 3 over 4. And we should be able to get the same r when we have 3 over 4. And this is when we have the theta is equal to 11 pi over 6. Okay, it's basically to list out all the coordinates. Okay, since the question actually asks for it. Okay, we just have to calculate each and every one there. So these points are actually going to help us, okay, in the sketching in the later part. So when we actually want to sketch in the later part, so what we have in this case is, so we can actually see that there are actually a few things that is the r d theta is equals to 0. So that means we could have the maximum r or the minimum r in that case. So if we actually try to mark all those points on the graph, right, we have got when theta is equals to pi over 2, we have r is 3, and theta is equals to 3 pi over 2, the r is a 1. Okay, and then we have got when theta is equals to 7 pi over 6 and 11 pi over 6, so both of them are 3 over 4. So basically the 3 over 4 are actually quite small here. Okay, so let's just mark the points like this here. And we have so this is the 4 points that we have, and then it is also good for us to find out what is the starting point. Okay, so for this case, when we actually have the theta is equals to 0, the r is equals to 1. So this same thing goes to when theta equals to pi, the r is equals to 1 as well. Okay, so we expect the graph will actually passes through these points. So how do we actually sketch this is to join all this. So it's just at here 1 goes to 3 goes to 1 again for our r, and then when it actually pass through the theta equals to 7 pi over 6, it has a minimum because that is 3 over 4 is the smallest among all these points here for the r. Okay, and we have a little bit of turning to actually touches the 3 pi over 4, the r is equals to 1. So for this one, we have to go back again as the minimum r here, and then we have to go back to the 1 again. Okay, so we actually get a graph which a bit looks like a mushroom. Okay, so you can always use a plotter to check whether you get the graph correctly or not. Okay, so that is for the question. Okay, next one we are going to look at summer 13, this question 6. So the curve P has a polar equation given by this. Okay, r is equals to 1 over 1 minus sine theta. So determine the Cartesian equation of the P. So for this one, okay, is to use all the properties that we know about the Cartesian and the polar. So let's just move up the 1 minus sine theta to multiply by the r from there. Okay, so this is what we have, r minus r sine theta. So we know that the r sine theta is a y. So we have 1 plus y from there, let's say. So in that case, okay, because we want to eliminate the r in this equation, so let's say we square both sides. So when we square the 1 plus y, we have 1 plus 2y plus y squared. So what do we have for the r squared? Is that we have x squared plus y squared for the r squared. So basically after that is just evaluate to eliminate, the y squared, and we rearrange the equation a little bit. So basically, surprisingly, what we get is we actually get a quadratic curve. Okay, so that would be the equation, the Cartesian equation of this P, but this represented in the polar form in the beginning. Okay, so part 2, to sketch the P in this case. So we already know this curve is a quadratic curve, and it is so easy for us to actually sketch this curve. So half x squared minus half is not something difficult to sketch. Okay, so this is basically what we have for the curve. So this is our negative half. And then if you want to find out the x-intercept, the x-intercept will be a 1 and a negative 1. Very easily. Okay, so part 3. Okay, we are asked to evaluate from pi to 2 pi, okay, 1 over 1 minus sine theta squared. So what do we actually mean by this one is this is actually integrate r squared d theta. Okay, so what can we relate to the integrate r squared d theta is that it's basically the area, but this is not really the equation that we use, the formula that we use for the area, unless we actually do this. Okay, so what do we have for this one is integrating this expression is the same as to find out 2 times the area. Okay, because these two expressions here are the same. So evaluate this means we need to find out 2 times the area of this curve. Okay, but from what values of theta to what value of the theta is that the theta here is from pi to 2 pi. So what do we have from the pi to 2 pi is that if I actually refer this sketch again, pi to 2 pi actually means here. So basically what we have in this case, okay, for this integral is that we're actually evaluating 2 times the area of the curve. Okay, so for this curve basically, so we are evaluating like 2 times the area. So we need to find out what is the area in between this, okay, -1 to 1 for this curve. Okay, so basically what we have is we are actually looking at 2 times, okay, the area of this curve from x equals to -1 to 1. So the function of this curve is given by this. Okay, but now another thing that we have to be careful is that we are asked, okay, again to find out this. So this is the thing that we want to evaluate. So if we were to do that by using the polar, as if we just integrate by using this usual one, okay, the half r squared d theta is an area. So if it is an area, we are not supposed to get a negative value, okay? But what we are working with here is we are working with a Cartesian equation. So when we have the Cartesian equation in this case, the area of the curve is below the x-axis. So if we will use this, we will actually get a negative value. Okay, but it is an area, so we cannot just do this. So instead what we need to do is we need to negative it. Okay, so once we do this, okay, we will see the next step. So once we do this, we actually have -1 to 1. In this case, it's a 1 minus x squared. Okay, so we have to integrate this one. So evaluate this, okay, integral at -1 to 1. So basically, if you actually integrate it, we will get a 4 over 3. So we actually get a positive value. Okay, so this is the answer for the integral that it is asked, okay, in the question. Okay, so again, this, okay, is actually equals to 2 times of the area. Okay, so this is why we do this. We use 2 times okay, of the area, but instead of using the polar equation, we use a Cartesian equation to find the area. And then another thing is, because it's an area, so we have to negative it before we actually integrate, or after you integrate, you just ignore the negative, because again it's an area, so you are supposed to get a positive value from there. Okay, so this is another question which is like a bit special, okay, and it's rather challenging. Okay, so we will look at the another question. So this question is from summer 11, okay, the question 13. So for this one, it actually involves quite a lot of things. In the part 1, it's not really something that is related to polar, but we are going to need this, okay, later. So for the first one, given that t is equal to tangent x, we need to prove that 2 over 2 minus sine 2x is equal to this expression. So basically for this one, it is not difficult to prove. We just need to, given that we have got t is equal to tangent x, in that case, we are actually able to write, okay, the expression for cos and the sine in terms of t. So given that the x is acute angle, so we can rely on this. So the tangent is opposite divided by adjacent. So we have got t over 1. Okay, so that gives us the hypotenuse is 1 plus t squared with a root. So we can write the cos x and the sine x easily for the expression. So the sine x is t over 1 plus t squared. Okay, so with this we can actually express all the tangent, cos and sine in terms of t. So we have got the expression to write. So we have 2 over 2 minus sine 2x. So this is basically the sine 2x, we can actually write that as 2 sine x cos x. Okay, and we have got the 2 can be cancelled off from numerator and denominator. So what we have is we only have 1 over 1 minus sine x times cos x. So when we have sine x times cos x, by using the expression that we have found earlier, we have got t over 1 plus t squared. Okay, so basically after that is just by doing the manipulation, we should be able to find, okay, the expression that we need to prove. Okay, it's a 2 marks question. So B, hence determine the value of the constant k. Okay, for which we have when we differentiate this expression, it gives us a nice expression, okay, which is related to what we have proven earlier on. Okay, so for this one, okay, what we can actually do from here is we can actually look at the differentiation here. Okay, so what we have from this one is we have got the arctangent. We're supposed to differentiate this expression here. Okay, we have got arctangent of 1 minus 2 tangent x divided by root 3. Okay, so for that one, right, we need to differentiate the arctangent. So inside the arctangent, we have got that expression. So let's say we just let the u to be that expression first. Okay, because we are going to differentiate a quite complicated expression, so let's just make the expression inside the arctangent as a u first. Then we'll know that for this one, we actually have, if we want to differentiate tangent u with respect to x, so this is du dx. Okay, this is dy du times we have got du dx. So this is basically by using the chain rule. So when we actually substitute this u in, we have got, so this is not so friendly to work with, just make sure we actually be careful. Okay, we have got u squared times the du dx. So du dx means we have to differentiate this, okay, 1 minus 2 tangent x over root 3. So that will actually gives us negative 2 over root 3 and we have got secant squared x. Okay, so after that is to tidy up, okay, everything that we have here. So when we actually try to tidy that up, okay, we'll actually have negative 2 secant squared x. And for the denominator is a bit more work to do. So we multiply the root 3, okay, to the denominator. So what we actually get is we will actually get root 3 plus 1 minus 2 tangent x, the whole thing squared, divided by root 3. So to make this everything nice, we have to multiply both numerator and denominator by a root 3. So in denominator, we will actually have 3 plus, we expand the 1 minus 2 tangent x squared. Okay, so this is what we get after we expand. And from there, okay, we have the tangent x, okay, and for the secant squared, we can always write that as 1 plus tangent squared. So if we let the t to be tangent square x, okay, like what we have in the earlier part, so for this one, we'll actually get negative 2 root 3, 1 plus tangent squared divided by, so for the denominator, okay, we will actually have 4 minus 4t plus 4t squared. Okay, for which we can actually simplify that a little bit to make it the same as what we have in the earlier expression. So we just keep the 2 there, okay, and then we just factorize the 4 out. So at last what we get is we'll get negative root 3 over 2. Okay, from there is 1 plus t squared divided by 1 minus t plus t squared. Okay, so for that, 1 plus t squared, 1 and 1 minus t plus t squared is we have negative root 3 over 2. So use the result in the earlier part. So we have got 2, and we have 2 minus sine 2x. And in this case, we can actually cancel off the 2's. So we will actually have negative root 3 divided by 2 minus sine 2x. So in this case, our k is a negative root 3. Okay, so this is how we find the k. Alright. Next is to look at the second part of the question. So we have got this curve C has this Cartesian equation. So we need to determine a polar equation in the form of r squared is equal to f theta. So deduce, okay, the polar coordinates on the point of C which are furthest from the pole O. Okay, so this is a 7 marks question. So basically is to work with the Cartesian equation first. Alright, so for the second part, we have got the Cartesian equation x squared minus xy plus y squared is equal to 72. So we know that x squared plus y squared is r squared. And then we also have x is r cos theta, y is r sin theta. So that actually gives us r squared sin theta cos theta. Okay, so we just keep the r square there, and then we factorize out the r square, and the rest we just bring it down. So we have got 1 minus sine theta cos theta. Okay, so if we want to make it nicer, we can actually multiply by 2 for both numerator and denominator. So the reason that we want to do this is we want to get something which is very similar to the expression that we have earlier. So you can see that here the denominator is actually 2 minus sine 2 theta. Okay, so the question also mentioned about the furthest, okay, from the pole O. So we want to look at like the maximum. point in this case. Okay, so how do we actually look at the maximum r in this case is that, so because the r square is only depending on the sine 2 theta. Okay, so in that case the sine 2 theta is in the denominator, so we need to have the minimum sine 2 theta in order for us to give us the maximum r square. Okay, so we have the r square is maximum when, of course, we want to have the sine 2 theta to take the least value. Okay, and in this case we have a negative sine 2 theta, so in order for us to get the maximum value, the sine 2 theta must be a 1. Okay, it cannot be negative 1 because if we have sine 2 theta is negative 1, we have 2 minus negative 1, which is 3. So the denominator is higher already. So if we have higher denominator, means the r square value will be lesser already. So we want to have the least value in the denominator. So this will happen when we have sine 2 theta is equals to 1. So if we have sine 2 theta is equals to 1, okay, so in that case, the r squared is 144, for which the r is 12. Okay, so when will this happen is when we have the 2 theta is equals to pi over 2, where we have the theta is equals to pi over 4 in that case. Okay, so this is the point that we actually have for the maximum. So not to forget, we actually have another value, because other than this pi over 4, we can also have 5 pi over 4 to give us the sine is equals to 1. Okay, so we have got 2 points. Okay, because remember the theta is from 0 to 2 pi. Alright, so the 2 points that we have for the maximum is that, so the r is a maximum when we have got these 2 points. So r and theta. So r theta and also r theta. Okay, so just have to take note that we have another value, which is 5 pi over 4. Okay, to give us a sine 2 theta is equals to 1. Okay, the last part from here is find the exact area of the region of the plane in the first quadrant bounded by C, the x-axis, and the line y is equals to x. So deduce the total area, okay, lies inside C and within the first quadrant. So what happened to this one is that, okay, we have to find out the area where it is in the first quadrant bounded by C, x-axis, and also the line y is equals to x. So we all know that the line y is equals to x is a line that is pi over 4 radian to the positive x-axis, or in this case is the initial line. So it is something like this. So this is like, let's say, our curve, and then we have got this is y is equals to x. So basically the angle here is a pi over 4. So we are only looking at the area in between from 0 to pi over 4 for this curve. Okay, so in order for us to find the area in this case, so we are integrating half r squared d theta. So in this case, the r squared is already given, and we are integrating from 0 to pi over 4. So we don't have to square this anymore because this is already in r squared. Okay, so like what is the purpose that we do all those things earlier is that we need to relate this to what we have done earlier. So remember, we have in the previous part we have got this one. We are asked to express into this form where we have the negative root 3 2 minus sine 2x is to use this result. Okay, so what happens is that we can factorize out the 144 and then multiply the numerator and denominator by negative root 3. So 144 divided by 2 is 72, but we need to multiply the numerator and denominator by negative root 3 first. So the reason again that we want to do this is because we want to apply the previous result. Okay, because we do not know how to integrate this one. Okay, but in the previous result it has already helped us. So we have got this k here is a negative root 3. Okay, so we know that when we actually integrate this one, we will actually get this result. Okay, so we can just apply the result from there. So we have got 72 over negative root 3. So the result is just the whole bunch of arctangent, and we have got 1 minus 2 tangent theta divided by root 3. So this whole thing. Okay, and the result, okay, that we actually evaluate the pi over 4 and 0, we will actually get arctangent of negative 1 over root 3 minus arctangent of 1 over root 3. So this is 72 over negative root 3. So arctangent of 1 over root 3 is a negative pi over 6, and another one is a pi over 6 as well. So just tidy up this one. Okay, we will actually get 8 root 3 pi. Okay, so this is the area from this part. Okay, 0 to pi over 4. We also have another part of the question as well. So deduce the total area of the region, okay, within the first quadrant. So for that one, the area within the first quadrant is just equals to 2 times 8 root 3 pi, which is 7 root 3 pi. Okay, due to the fact that we have got the r squared is equals to 144 over 2 minus sine 2 theta. So for this sine 2 theta, it is symmetrical. Okay, about the theta is equal to pi over 4 when we have the first quadrant. Okay, so the graph will be identical from 0 to pi over 4 and from pi over 4 to pi over 2. So that will be in the first quadrant, the pi over 4 will actually divide them equally into 2 parts, because this sine 2 theta function is again symmetrical at pi over 4. So with that, we just have to multiply by 2 from the area that we have found earlier on. Then we can actually get the area, which is for the whole first quadrant. Okay, so that's all that we will actually discuss for this video. Thank you.